In section 1.3, we begin our study of linear equations in two variables. Before we jump in, let's pause for a minute and remember where we've been. In section 1.1, we studied linear equations in one variable. An example of a linear equation in one variable might be something like 2x plus 3 equals 5. When we solve that equation, we end up with a single solution, x equals 1. Then, in section 1.2, we progressed to linear inequalities in one variable. An example of a linear inequality in one variable might be 2x plus 3 greater than 5. We learned that the solution to a linear inequality in one variable is a whole interval of solutions. We learned how to express those solutions in interval notation. Thus, we get an infinite number of solutions for an inequality, whereas we get one distinct solution for a linear equation. Now, we're going to progress to linear equations in two variables. So we'll begin with the definition. A linear equation in two variables can be written in the form ax plus by equals c, where a, b, and c are real numbers and a and b both cannot be 0. So our variables here are x and y. Both of these variables are raised to the power of 1, which classifies the equation as a linear equation. Now, instead of having an interval of solutions like we did with an linear inequality in one variable, we're going to have solutions on two number lines, an x-axis and a y-axis. The solution to a linear equation in two variables is an ordered pair, x, y, that balances the equation. For each linear equation in two variables, there's an infinite number of ordered pair solutions. So in general, we express these solutions on a graph. The shape of the graph of a linear equation in two variables is a straight line. That's where we get the name linear equation. In this section, we're going to learn how to graph lines using two different methods. In section 1.3.1, we'll study graphing lines in standard form. When we see a line in standard form, that is, the x and y variables are together on the left side and the constant term is on the right, we will graph these by plotting the x and y intercept. This is a fast, easy, efficient way to graph the line. Now, recall the y-intercept is where the line crosses the y-axis. And remember, the y-axis is the vertical axis. The x-intercept is where the line crosses the x-axis. To find the x and y intercepts, we're going to be setting the opposite variable equal to 0. To find the x-intercept, set the opposite variable y equal to 0 and then solve for x. When we set y equal to 0, that locates the point somewhere on the x-axis. The form for the x-intercept then is going to be some number for x and 0 for the y-coordinate. Now, to find the y-intercept, we set the opposite variable x equal to 0 and then solve for y. The form for the y-intercept will be ordered pair x equals 0 and then some number c for the y-coordinate. Let's practice graphing a line in standard form using the x and y-intercept. Example 1. Graph the following standard form equations by determining the x and y-intercepts. Express the intercepts as ordered pairs and label the intercepts on the graph. The equation we'll begin with is 2x minus 3y equals 12. Let's start by finding the x-intercept. The plan for doing this is to set y equal to 0. Looking at the original equation, we're going to replace y with 0 and solve for x. This looks like 2x minus 3 times 0 equals 12. Since 3 times 0 is equal to 0, we end up with now the linear equation in one variable, 2x equals 12. And we can solve for x by dividing both sides by 2, and we get x equals 6. But we want to be official and express this as an ordered pair. So, ordered pair means alphabetical order. The x value goes first, and remember we set y equal to 0 at the beginning of the problem. So because y is 0, this number is on the x-axis. So I'm going to go to the right by 6 units on the x-axis and make a point. So that's our x-intercept, 6, 0. Now we're going to find the y-intercept by setting x equal to 0. So to find the y-intercept, we set x equal to 0. Now I'm going to go back to the original equation and start new. I'm going to replace the x coordinate with 0. We have 2 times 0 minus 3y equals 12. 2 times 0 is 0, so we end up with the linear equation in one variable, negative 3y equals 12. We can solve by dividing both sides by negative 3, and we end up with y equals negative 4. Officially, we'll express this as an ordered pair. We set x equal to 0, and we found y equals negative 4. So on the graph, we'll plot the point 0, negative 4 on the y-axis. Now, it only takes 2 points to determine a line. So once I have my 2 points plotted, I can carefully connect them with the straight line, and we'll have the line graphed. Now, if you're working at home, I strongly recommend using a ruler here. I'm going to do my best on my computer screen, to draw a straight line right through my label. And then I'm going to go ahead and label the line with its equation. So the idea is that every single ordered pair on this line solves the original equation. So we have an infinite number of ordered pairs, and the pattern that they make in the coordinate plane is a straight line. So this is a pretty simple process. Let's practice that again on example B. 3x plus 5y equals 15. Notice it is in standard form because x and y are together on one side and the constant is on the other side. When your equation is in this form, it's convenient to graph it by plotting the x and the y-intercepts. So let's calculate those. The x-intercept is found by setting the opposite variable y equal to 0. So when we plug 0 in for y, this term goes away and we end up with a linear equation in one variable. It's very easy to solve by dividing both sides by 3, and we get x equals 5. So officially, as an ordered pair, our x-intercept is 5, 0. We can plot that on our coordinate plane at location 5, 0. Now let's proceed to find the y-intercept. The y-intercept is found by setting x equal to 0. So going back to the original equation and replacing x with 0 this time, we can then solve for y. So our first term goes away and we end up with the simple equation 5y equals 15. Divide both sides by 5 to solve for y, and we end up with y equals 3. Officially, as an ordered pair, this is x equals 0, y equals 3. So we can plot that on the y-axis, 0, 3, and make our label. And then once we have those 2 points, that is sufficient to determine the line. So I'm going to very carefully connect my dots using a straight line. And then we can label it with the equation 3x plus 5y equals 15. So it's a very simple process to graph a linear equation in standard form by plotting the x and y intercepts. Now, later in the semester, we'll be finding x and y intercepts for nonlinear graphs, but the process will be the same. To find the x-intercept, we set y to 0. To find the y-intercept, we set x to 0.